here's the deal. Today we talk about, not that. Today we talk about what's called inverse variation. If you remember, and this is probably easier to understand if we go back and talk about the other type of variation we talked about, which was direct variation. So put off to the side here, and this was all last year, so you won't remember this before. First of all, we had the direct variation equation, which was y equals k times x. Where the letter k is what we call the constant of variation. And really, direct variation is simply this: as one goes up, the other goes up. As one goes up, the other goes up. It's usually, when we think of variation, we usually think of this. The other goes up. Okay. And a good example is this. You guys are getting about the age where you almost could pick up a summer job. Let's say you get a job and you make I don't know, $8 an hour. Unless you work at McDonald's in the city, then you make 15, but that's nice. Okay. So if you are looking to write an equation for that, if we're making a table for how much you're going to get paid, you work 0 hours, 2 hours, 4 hours, 6 hours. This is direct variation because the formula for that is y, the amount of money, y is going to be the money, x is the number of hours, y equals $8 times x. Correct? You work no hours, you get no pay. You work 2 hours, you make $16. 4 hours, you're going to get $32, and 6 hours, you're going to get $48. That is direct variation. The more hours you work, the more money you make. Okay? And this is usually what we call the direct variation equation. Y equals. That has nothing, well, it does have something to do with what we're going to do today, but it's good for you to understand it because they'll ask you, is this direct variation or inverse variation? Inverse variation, ladies and gentlemen. Just get rid of this. Put this out of your thought for a little while. Maybe I should blow this up. Let's blow this up. Inverse variation is this. If it's inverse, it's the other way. In other words, as one goes up, comma, the other actually goes down. Okay? As one goes up, the other one actually goes down. And its equation, you can write it a couple different ways. A couple different ways that you can look at it. You can look at it like this, still using x, y's, and k's. X times y equals k. Or if you maneuver that around a little bit and divide out the x, you could also say that y equals k divided by x, because you divide by x to solve for that. These are both inverse variation equations. Okay, now, what would be an example of inverse variation? Anybody? How about this? Inverse variation would be the speed you go travel and the distance and how long it takes you to go somewhere. And how long to travel so far. Okay, so let's say, here's something that's inverse variation. And the book will say it like this. Well, I guess it's like that. let's say you need to go 100 miles. How long will it take you to go 100 miles? Well, let's make a table here. Really? Can't I go with a different color? Let's say you are traveling at a speed, x is your speed, x equals speed, and y equals time. If you are going 20 miles an hour, how long is it going to take you to go 100 miles? David, this is a tough one. You need to travel 100 miles to your next football game. Your father being a heavy-footed, fast-paced driver, which I hear he is. Sorry about that, Mr. Swenson. He drives at a blazing speed of 20 miles per hour. How long is it going to take him to go 100 miles? 5 hours. So, bam. Let's say then Caleb Cook's mom is driving the vehicle, and she's known for super speeding, and she is going 50 miles an hour. Caleb, how long is it going to take you to go that 100 miles? 2 hours. So do you see the inverse variation there? X went up and Y went down. You know, let's say Noah Clausing jumps in an airplane. He's going 100 miles an hour. Noah's going to get there in, what's that? 1 hour. Thank you very much. 1 hour. Okay. Now here is the, well, let's look at this. So what would be our things here? What is our constant of variation be? Would it be? Because that's what they'll ask you. What is the letter K? Well, all you have to do is look at this. X times Y gives you what your K is. What is my X times Y every time here? In this equation, it would be X times Y is X times Y is X times Y is. What's 20 times 5? What's 50 times 2? What's 100 times 1? 100, yeah. So this would be your inverse variation equation. Y equals 100 divided by X. And this, I'm going to blow this up in hyperwarp so you can see this, because this will get you. Anytime they ask you about inverse variation, really this is all you have to think about. These two numbers multiplied together always have to give you the same thing. So you know this is 100, you know this is 100, and you know this is 100. Okay? But you won't know. Here, let me give you a for example here, and that's really big, so I'm going to be drawing really big. If y varies inversely as x, well here's one right out of the book. If it takes 3 people working to do a job in 5 hours, does this say? Yeah, right, just if 3 people can do a job in 5 hours, comma, how long would it take 5 people to do the job? Now, the first thing you want to kind of sit back and say, what kind of variation is that? If you have more people, is it going to take longer to do the job or fewer hours to do the job? Fewer hours. So that's inverse variation, because the more people you have, the other one's going to go down. So if that's the case, here's the whole thing, and look how easy this is. You can just sit here and make this table you know this is number of people and this is the time. It takes 3 people 5 hours to do it. How long would it take 5 people to do it? And this is all you have to think about. You know, we just talked about this. I'll go back and show you. We just talked about this. These two numbers equal 100. These two numbers have to equal that same thing. So if you go back to this, these two numbers multiplied together equal what? 15. These two numbers, 5 times this number, has to also equal 15. So 5 people, it would take how long to do? 3 hours. If you had 15 people, it would take them how long to do it? 1 hour. Because they have to always equal the same thing. What would be the equation? The inverse variation equation would be y equals 15 over x. Because whatever this number is your constant of variation. Or you could rewrite it also as xy equals 15. Either way, it's the same. I can tell you're very, 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 very excited about that. One more problem. Letter G on practice, which you don't have, says the volume in an air balloon and the air pressure in the balloon are inversely proportional. How about that? Can I write that down? Yes, write this down. Volume of air in a balloon speaking of double consonant words, balloon. Is that another spelling word? And the air pressure are inversely proportional. You see that word inverse, you should automatically think of that whole thing we just talked about. As one goes up, the other one goes down. Okay? If the balloon is squeezed to half of its original volume, if balloon volume is squeezed to 1/2, by what factor does the air pressure increase? By what, oh boy, this is going crazy, factor does pressure increase? That's pretty crystal clear, isn't it? Somebody want to speculate on that? Now, do you see some hard numbers there? Does it tell you what the volume or the pressure are? Stritzel?
No.
What do you suppose you should do if it doesn't tell you? Oh, you're right, it doesn't.
Make it up.
Thank you. So you can sit there and do that. So here we go. We're going to make a little table. Make a little table. Make a little table. And pick any number you want. Let's just start with 4. What's that? 4. Okay. So if the, what is this first one given? If volume is 4, let's say the pressure is, and again, you actually, can you make this up? Yeah, let's make up a number. Will it work if we make a number up? Sure. Let's pick a number for the pressure. Let's say the pressure is 4. Right?
Yeah.
So what would be my constant of variation then? 16, right? You have to multiply those two together. Now what did they say happened? The ball volume was cut in half. So what would that make the volume now? 2. And then what would this have to be in order to give you 16? 8. So the question they ask you is this: by what factor does the pressure increase? So my pressure went from 4 to 8. What factor, what would you multiply that by to get there? 2. So basically it's times 2 or the double. A little bit of thought provoking there, isn't it? Which, by the way, here's another, this will astound and amaze your friends. If you are graphing inverse variation, we will end on this because you will be so excited when you see this or just mesmerized. We're going to just make up a number here. Let's make up something. Let's make up a table that shows inverse variation. It doesn't really even matter what it is. But let's make it reasonable so that it's something that can fit on a graph. Let's say x is 1. What do you want y to be? Taylor Rice, let's make it something reasonable. Within like between 1 and 10. 2. Did you say 2? Okay. Do I like 2? 2 will work, I guess. Here, check this out. We are going to make a massive table here. I'm not sure how much we can do. We know this is inverse variation, so we know the constant of variation has to be, multiply the two together. Everything we put down here has to get multiplied and get 2. I'm not sure how many different factors we're going to get here, Taylor, but I guess we'll try. Let's pick a different one. Just go 4. Can we go with 4? Okay. So, if x is 2, then y is 2. If x is 4, y is 1. If x is 1/2, 1/2 times what number gives you 4? 8. If x was 1/4, 1/4 times what number gives you? 16. Sure. 1/4 times what gives you 8? Flip it, multiply. 4 times 8 is 32. What if it was 1/16? 16 times 4 is 64. Here's your question. What about 0? 0 times what gives you 4?
Is that even possible?
Exactly, it is not possible. Okay, when you have inverse variation, you have what we say kind of like our limits. There's a different name over there. You can't do 0. It will approach 0, but never get to 0. Same thing here. You could never have 0 for y because 0 times nothing would give you that. When you graph inverse variation, this is the graph of that. And all inverse variation will look alike here. Let's do it. 1/4. I'm going to make it really big because we don't have much numbers here. 1, 2, 3, 4. 2 is 2. 1, 2 was 2. 1/2 was 8. Here's 1/2. 8 would be way up here. 1/4 was 32. It's going to keep getting close to that. I get it there. What if y was 1/2? Does it make sense that x has to be 8? Because these two have to give you the same number. So if x is 8, 2, 3, 4, 5, 6, 7, 8, we get 1/2. If x was 1/4, y would be whatever, 132. This is the graph, and you notice it's not a linear line, it's not straight. The graph of this always gives you something that looks like this. It is a curvy, archy sort of line that will come to but never ever get to those zeros there. It will never get to that thing. It'll get really, really close, but it'll never get there. David Swenson, because you dropped your whatever that was. If x was 1/1000, what would y be? Yeah, 4,000. So if you were like this little thing right here, you'd have to go up way up 4,000, and that's how close we would get to that. Anybody feel